we are going to start the structure of atom. In the structure of atom, already we have discussed the discovery of electron, discovery of proton, discovery of neutron, Thomson model of an atom, and Rutherford alpha scattering experiment. All these things I have explained. Apart from this one, we are going to start today what is isotopes, what do you mean by isobars, what do you mean by isotones. First, what is isotope? Isotopes are the species which have same atomic number but different mass number. Is it clear to you all? Isotopes are the species which have same atomic number but different mass number. In this case, you see 1H1, that is this is the isotope of hydrogen, which is called protium. 1S2, isotope of hydrogen, which is called deuterium, and 1S3, which is the isotope of hydrogen, called tritium. Exactly same way, isotopes of oxygen are 8O16, 8O17, and 8O18. Alright? So, what do we see? Isotopes means same atomic number and different mass numbers. Now we come to isobars. In isobars, what do we see? Just opposite. Atomic number will be different, but mass number will be same. Those species which have different mass number, different atomic number, but similar mass number are called isobars. As for example, you see 18 argon 40, 20 calcium 40, 19 potassium 40. 40 is common for all, that is same mass number, but atomic numbers are different, that you see 18, 20 and 19. So I do hope that you might have understood very clearly what do you mean by isotopes and what do you mean by isobars. Now isotones. In the case of isotones, what do we see? Isotones are the species which have same number of neutron, 14 silicon 40, 15 phosphorus 31, 16 sulfur 32. Now check it here. 40 minus 14. Alright. What do you see? 6. That you are having 26. And now see in this case 31 minus 15. 31 minus 15. What do we see? Again 26. Again you are having 26. Same way 32 minus 16. Alright. You are having again what? 26. Oh sorry. Same number of neutron you have to get, no? So same number of neutron, what you will do? In this case you see 40 minus 14, 31 minus 15 and 32 minus 16. You will find in all the cases you are getting the same number of neutron. Now, once more, this small thing is there, and class 10 also have studied isotope and isobar. Just after this one, we are going to start the electromagnetic spectrum. But before starting the electromagnetic spectrum, we have to make it very clear that what is wave? What is wave? What is amplitude? What is frequency? Now see this one. The first one I'll make it clear. See, you assume that this is your wave. In this wave, you check it here that this is the height of your wave and this is the depth of your wave. So this is again height of wave, this is the depth of wave, height of wave, depth of wave. Alright. Now see, when two consecutive height, the distance between two consecutive height is called wavelength, that is called lambda, or the depth of two consecutive amplitude, this is also your lambda. So this is your crest, upper part, this is your crest, crest, and this is your trough, troughs. Do you understand? So in this way, what do you find? That two consecutive crest or two consecutive trough is called lambda, that is your wavelength. Then what is frequency? Frequency means the number of passing of waves through a particular point in 1 second is called frequency. One wave you have seen, another wave I am writing this one. See, this is also wave. Third wave I am writing this one. What do you find it here? If a particular point we are fixing, the number of passing of the wave will be maximum in this case, then in this case, then in this case. So 3 waves you are taking, wave number 1, wave number 2 and wave number 3. What do you find? That wavelength is maximum in this case, frequency is minimum in this case. Wavelength is minimum in this case, frequency is maximum in this case. It means frequency is just opposite to the wavelength. Alright? Now, amplitude. Just now I have told you amplitude. Amplitude is a height or depth of crest or trough. That is your amplitude. And then wave number. Wave number is the reciprocal of wavelength. Wave number, nu bar, that is wave number. Wave number equals to reciprocal of wavelength. Means 1 by lambda. That is your wave number. So reciprocal of wavelength is your wave number. Now we have understood what is wave nature. In wave nature, what is lambda, what is frequency, what is amplitude, what is wave number. Now we discuss the electromagnetic spectrum. Electromagnetic spectrum, what do we see? We start from here, cosmic rays, then gamma rays, then X-rays, then ultraviolet rays, then visible rays, then infrared, microwaves, radio waves. You see, arrow I have given in this way, and just after arrow I have given lambda. Lambda means wavelength is increasing from left to right. It means cosmic rays is having the minimum wavelength and radio wave is having the maximum wavelength. Just down you see, we have given the arrow of nu, this side. Nu means your frequency. Nu is your frequency. Frequency is increasing this side, opposite side of the wavelength. So, cosmic rays is having the maximum frequency and radio wave is having the minimum frequency. Alright? Any problem? Here itself I told you that when lambda means wavelength, when wavelength is increasing, at that time nu, that is frequency, is decreasing. Alright? Now, when we see in this case, cosmic rays, gamma rays to the radio wave, wavelength is increasing and frequency is decreasing. But when we come from radio waves towards cosmic rays, then frequency is increasing and gamma and wavelength is decreasing. Middle one is given here, visible range. See, visible region. Visible region is the region in which we see anything. Above visible region, below visible region, we can't see anything. Understood? So visible region means, I have given here 3800 angstrom to 7600 angstrom. 1 angstrom equals to 10 inverse 8 centimeter or 10 inverse 10 meter. Alright. So, what do we find in the visible region? The minimum wavelength is having violet, then indigo, then blue, then green, then yellow, then orange, then red. It means red is having maximum wavelength. And maximum wavelength they are having means minimum frequency they are having. They are having minimum frequency. Alright. So again arrow you can give from this side that frequency is increasing this side. It means violet region is having maximum frequency and red light or red region is having minimum frequency. Maximum wavelength, minimum frequency. Alright. Afterwards, in next class we will discuss the hydrogen spectrum and related things. Thank you.